In this problem, we are given the magnitude of the vector in this figure, and we're also given its angle, theta, which we can see from the diagram, is being measured from the positive x-axis. The problem is simply asking us to break the vector up into its x and y components and determine those components. This problem is fairly straightforward. If we have a vector that is at some angle being measured from the horizontal axis, then the horizontal component, or the x component, r sub x, is equal to the magnitude of the vector multiplied by the cosine of the angle theta. The y component, or the vertical component, r sub y, is equal to the magnitude of the vector multiplied by the sine of the angle theta. Note that these two formulas only work if the angle theta is being measured from a horizontal axis. If it's being measured from a vertical axis, for example, instead, then we'd have to use the same formulas, but flip where we have the cosine and sine functions. So the x component would be r times the sine of theta, and the y component would be r times the cosine of theta. But we can just use the normal convention here. So for part A of the problem, which asks for the x component of r sub x, is going to be equal to the magnitude of the vector, which is given in the problem as 15 meters, multiplied by the cosine of the angle theta, or 30 degrees, which, if we put this into a calculator, and make sure your calculator is in degree mode and not radian mode, we find to be about 13 meters. For part B, we'll now find r sub y by using the same formula, so 15 meters, only now we're multiplying by the sine of theta, so the sine of 30 degrees. Put this into a calculator, and we find about 7.5 meters. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making future videos just like this. And if you have any requests or questions, leave a comment down below. That's all for now, and I hope you have a lovely day. Bye-bye.